the science classroom, class 10th, chapter 1. Today's topic is chemical reactions, types of chemical reactions. You know, during a chemical reaction, either energy is required or energy is released. Depending on the energy released or requirement, the chemical reactions are of two types. Right? Number one, exothermic reaction, and number two, endothermic reaction. In case of exothermic reaction, the energy is released. Clear? When the reaction proceeds, the energy is released. Often you might have observed, when you are doing some reactions in a beaker, and if you touch the beaker get heated. Those reactions where the beaker get heated automatically without supplying any heat are the example of exothermic reactions. Now you are in your body, respiration is going on. This respiration breaks glucose and releases energy. So that is also an example of exothermic reaction. Let's say in an example, have you seen the limestone, chuna patthar? Take that limestone in a beaker, put some water. What will say? The bubbles come out. You touch the pot in which you have taken, that is get heated. Even some hot air is also coming out from that. You can observe that one. That is also an example of exothermic reaction. So we can do one more thing. You can take some example here. First example is C6H12O6. When you take oxygen, it breaks down to give you carbon dioxide and water plus energy. Okay. One more example we will take here. Calcium oxide, that is chuna patthar. When you add water here, it gives you calcium hydroxide and tremendous amount of heat is released. You can take one more example here. The natural gas which is used in your house to cook your food, that is nothing but CH4. When it burns in presence of oxygen, it gives you carbon dioxide in gaseous form and water in gaseous form plus energy. So these energy which are released during this reaction shows that these reactions are of exothermic type. Next come to endothermic reaction. This endothermic reaction, energy is required to carry out the reaction. जब तक आप एनर्जी नहीं दोगे ये रिएक्शन नहीं होगा. Okay? For example, again the magnesium reburn. Okay? When it burns in presence of oxygen, you have to supply heat here. Right? You have to supply it. You can heat it with the help of Bunsen burner or a spirit lamp. Then only it will produce magnesium oxide. Right? So this is an example of endothermic reaction. Clear? A number of examples you will get while discussing the different types of chemical reactions. You can note it down and try to understand those reactions, whether it is an endothermic reaction or exothermic reaction. Next come to another way of classifying the chemical reactions. For instance, what happens during the chemical reaction? Do you think that any atom breaks and a new atom is formed, or oxygen itself changes to hydrogen, or hydrogen change to carbon. Is this going on? No. Just note it down. Atom do not disappear in the reaction. Atom cannot change from one type of atom to another type of atom. They restore their own originality. Then what happens? Actually, when a compound, for example, when a substance is there, in that their atoms are bonded with each other. This bond breaks. One more chemical, C plus D. Okay, these are the chemicals present, and this is also bond. Breaks. After breaking, what happens? Some new bonds are formed. The bond may be A and D forms new bond, B and C forms new bond, AD and BC. These are the new bonds are forming from this reaction. So, general talking, some substance breaks or the bonds between the atom of that substance breaks and a new substance is formed by the reshuffling of those atoms, and they forms new bonds and new substances are formed. Yes, take a example here. Sodium hydroxide plus HCl. Now they gives sodium chloride plus water. What happens? Sodium is a atom, oxygen and hydrogen another two atoms. There is a bond formed between sodium and oxygen and sodium and hydrogen. This bond breaks. Here also between hydrogen and chlorine, this bond breaks. Sodium combines with chlorine to give sodium chloride. New formation of bond is there. Similarly, OH combines with OH to form water. So this new bond is forming, old bond is breaking. So breaking and formation of new bonds are there, and the atoms get reshuffled, reunite to form new substances. Old substances are breaking and new substances are forming. This is happening during the chemical reaction. So depending on the way of formation of new substance and the way of breaking the old substances, there are 5 types of chemical reactions. So the first one is combination reaction. Second one is decomposition reaction. Third one is displacement reaction. Fourth one, double displacement. And fifth one is oxidation reduction reaction. Let's see what is the basic of these 5 types of reaction. Very simple one. As far as this combination reaction is concerned, as the name indicates, combination means something gets combined. Substance A combines with B to form a combination of substance, combination of atom A and B, where the chemical properties of AB is different from A and B. So this is a new substance. two or more things, 1 and 2, they get combines with each other to form a new compound. Cut. Next one is decomposition. In this decomposition process, a compound get broken down to its original elements. So it is a reverse of combination reaction. These reactions may be exothermic or may be endothermic. That depends on the requirement of energy or evolution of energy. Next one is displacement reaction. For example, this is a compound AB. When combines with C, B displaced by C and AC is formed plus B is replaced from the original compound. It is called displacement reaction. Now come to double displacement reaction. Here two compounds take part, AB plus CD. During the reaction, B replaces C and C replaces B. Then AD is formed plus BC is formed. Right? So, in both the cases, the elements get displaced or atoms get displaced. Hence, it is called double displacement reaction. Last one is the most important one. Here you will see two terms are there, oxidation and reduction. In this reaction, there are three ways to understand this type of reaction, because two processes are going on. Number one, oxidation. Okay, so there are three terms to understand oxidation. Number one, with oxygen, with hydrogen and with electron. With electron. Clear? So if hydrogen addition is there, if addition of hydrogen occurs in the reaction, it is called oxidation reaction. Right? If there is a loss of hydrogen is there in the reaction, yeah, if there is a loss of hydrogen is there in the reaction, it is called oxidation reaction. Or if there is a loss of electron is there, it is also called oxidation reaction. So what is reduction? In case of reduction, just reverse is true. In case of reduction, oxygen is in loss, hydrogen get added, and electrons also get addition. If any one of these three you observe in the reaction, accordingly you will give the title whether that reaction is an oxidation reaction or a redox reaction. Clear? Next come to the details with example about this combination reaction. In this case, two atoms or more than two atoms combines to give you a product. Yes, note it, a product. Take the example of your book, figure number 1.3, activities number 1.4, and it is at page number 6. Here, one beaker is there. In this beaker, we will take some lime, calcium oxide. Yes, it is called quicklime. Now pour it water. Pour it water. What you will see? As soon as the water come in contact with this quicklime, some drops, some bubbles comes out. And if you touch this beaker, you will observe the temperature. Means reaction is going on because bubbles are coming out, some gas is coming out. Okay, and also you observe the heat, and the reaction is calcium oxide in solid state. When you will add water of liquid state, you will get the reaction calcium hydroxide in aqueous plus heat. Got my point? And this product which is formed here is called slacked lime. This you are using in your house for whitewash during Deepavali. It is generally a little bit white yellowish color is there, but when you put it on the wall along with water, after some times you will say your wall gives the bright white color. How? When this calcium hydroxide come in contact with carbon dioxide of atmosphere, that changes to calcium carbonate plus water, so liquid, and this is solid. So this solidifies, and this is white color that glow on your wall, white finishing. This is one example of combination reaction, and is also an example of exothermic reactions. Take one more example. When charcoal burns in presence of oxygen, घर में आप कोयला जलाते हो ना, that gives you carbon dioxide. It is also a combination reaction. Similarly, when hydrogen gas combines with oxygen gas, that gives you water. One more example, the first example of your book, magnesium burns in presence of oxygen to give you magnesium oxide. Here also these two things combines to give one product, magnesium oxide. So this is what the combination reaction. So next reaction is decomposition reaction. Depending on the form of energy required to decompose or break down a chemical reaction, the decomposition reaction is of three types. Number one, thermal decomposition. Number two, electrical decomposition, where electricity is required. And third one is light decomposition, where sunlight is required. Let us see one example for heat or thermal decomposition. In your book, you can see the figure number 1.4, activity 1.5 and page number 8. There, in a hard glass test tube, you have to take few crystals of ferrous sulfate, which is green in color. When it is heated, it changes to ferric oxide, sulfur dioxide and sulfur trioxide. If you smell the gas that is coming out from the test tube, that gives you the pungent smell of sulfur dioxide. Actually the reaction is this ferrous sulfate, which is a crystal, contents of water molecules. 7 water molecules are there with this, and this is called hydrated ferrous sulfate or ferrous sulfate crystal. When it is heated, it gives you ferrous sulfate and water get evaporated, and this water is called water of crystallization. So when this green color crystal started gaining heat, it changes its color from green to white, then to reddish brown. So this color changes you can observe in that test tube. This reddish brown is because ferrous sulfate broken down to ferric oxide, sulfur dioxide and sulfur trioxide. Means one chemical broken down into 3 simple chemicals. Clear? Here heat is required, hence it is called thermal decomposition. Next come to second example of thermal decomposition, calcium carbonate. When it is heated, it gives you calcium oxide plus carbon dioxide. Yeah, this is your quick line. Take another example, that is activity number 1.6, figure 1.5 and page number 8. Here, in the same framework of experiment, in a test tube, lead nitrate is taken. It gives you lead oxide, nitrogen dioxide and oxygen. This is white color chemical. When it is heated, it gives you a brown fume. That also you can smell, or the color is visible. The fume color is visible to you, and that fume is because of nitrogen dioxide. So one chemical broken down into 1, 2, 3 products. Next one is electrical decomposition. The activity number 1.7, figure 1.6 and page number 9. Here one mug is taken, plastic mug, where 2 hole is made, and to it 2 electrodes are inserted with a rubber plug. Now this is filled with water, and this one is connected to battery. This one is anode or positive terminal, and this is cathode, negative terminal. It is connected to a battery of 6 volt. Clear? Now take 2 test tube and invert it over it. Put some dilute sulfuric acid and allow the current to pass through it. After some time you will see some bubbles coming out from here and from here. You will see that this is the mark. So at this point hydrogen is collected, and at this point oxygen is collected. Now see the volume of these two. Which one is more? It is in hydrogen. Why? Here when electric is passed, the reaction starts and the water molecules breaks. Let's see the reaction. Water under electrolysis, it gives you hydrogen plus oxygen, 2 balanced, then it is 2. So 2 hydrogen and 1 oxygen in the ratio of 2:1. That's why in this test tube we will got double in comparison to this test tube. This is oxygen and this is hydrogen. So now how to test that this is hydrogen and this is oxygen? Because they are colorless. Only water displacement shows that this much is empty and this much is empty. Do you think it is empty? It is not empty. Rather it is occupied with hydrogen gas and oxygen gas. So you have to bring a burning candle in front of this test tube. So take out the test tube inverted condition, revert it and show the burning candle. If you will get a white bright flame, that confirms it is oxygen. If you will get a blue flame with popping sound, then it confirms hydrogen. Next one is light decomposition. See your book, activity number 1.8, figure number 1.7 and page number 9, where one petri dish is there. In that silver colored crystal is taken, which is white in color. Clear? Now it is kept in sunlight for few hours, and you will see that this white color silver chloride crystal changes to gray color, because there is a chemical reaction occurs. Silver chloride changes to silver plus chlorine gas released out. So balance this equation. So silver, it is gray in color. As it is occurs in presence of sunlight, it is called light decomposition reaction. Same thing true with silver bromide. It also undergoes breakdown under light to give you silver plus bromine gas. This is silver bromide is yellow color and this is white color. Again grey color is formed. This chemical is used in black and white photography. Next one is displacement reaction.